Webb and Hubble captured detailed images of the DART impact. For a while now, the James Webb Space Telescope has received so much rave and attention in capturing images of space and outer planets, but the Hubble Space Telescope made a re-entry in the capturing of the DART impact images alongside the Webb. And in this video, we will be explaining everything about the DART impact. The James Webb Space Telescope and the Hubble Space Telescope, two of NASA's great observatories, have captured images of a first-of-its-kind NASA experiment. This test was created to purposely crash a spacecraft into a small asteroid in the world's first-ever in-space test for planetary defense. During NASA's DART launch into the asteroid, the James Webb Telescope and Hubble Telescope both captured the same celestial target at the same time. And before you get too anxious about what the DART is, it is NASA's Double Asteroid Redirection Test, which was used to test NASA's defense of the Earth from dangerous asteroids or comets, so don't worry, you are safe. NASA's James Webb Space Telescope and Hubble Space Telescope worked together to collect data before, during, and after NASA's Double Asteroid Redirection Test, which crashed into the asteroid moonlet Dimorphos in the Didymos Double Asteroid System at speeds of over 15,000 miles per hour. DART purposefully collided with Dimorphos, a pyramid-sized, rugby ball-shaped asteroid moonlet in Didymos' Double Asteroid System at a speed of 15,000 miles per hour on September 26, 2022 at 7:14 p.m. Eastern Standard Time. The Dimorphos are over 6.5 million miles away from Earth. It was the first test of humanity's kinetic impact mitigation measure, or let's say celestial damage control, which used a spaceship collision to divert and alter the orbit of an asteroid that presented no threat to Earth. The images obtained from the DART collision with Dimorphos are the first that the James Webb Space Telescope and the Hubble Space Telescope have observed and captured the same target at the same time. Surprisingly, both were successful, and they looked very similar to the images that the LICIA cube captured as it was 50 kilometers away from the asteroid. The James Webb Space Telescope and Hubble Telescope each saw a different perspective of the NASA test to divert an asteroid, since it was mainly to test if NASA was capable of preventing a global disaster if an asteroid or comet attacked Earth. The impact of the DART on Dimorphos was bigger than what the scientists planned, and upon the crash, scientists were worried that there would be nothing left of the Dimorphos. The James Webb Telescope and Hubble Telescope both captured the collision at different light wavelengths. Hubble captured the collision in visible light, while Webb captured it in infrared light. These measurements at various wavelengths will disclose the sizes of the particles in the developing dust cloud, allowing researchers to assess whether the collision created mostly little dust or numerous large pieces of debris. While NASA said that both the James Webb Space Telescope and the Hubble Space Telescope would attempt to capture the impact of DART with the asteroid Dimorphos, expectations were low because neither telescope was equipped to make such an observation. Before the collision, the James Webb Telescope observed the impact site before conducting numerous observations of the event over the next several hours. The images captured by the James Webb Telescope's NIR cam show a tight, compact core with wisps of material streaming away from the center. Because of the asteroid's fast transit across the sky, observing the impact with the James Webb Telescope offered significant challenges for mission operations, planning, and science teams. In the weeks leading up to the collision, the researchers worked harder to create and test a means of tracking asteroids traveling more than 3 times faster than the initial speed restriction set for Webb as DART approached its target. James Webb Telescope and Hubble Telescope will investigate the DART collision further to discover more about Dimorphos, how much debris was ejected during the crash, and how quickly it did. By integrating this data with images from ground-based telescopes, researchers can now understand how well a kinetic collision might affect an asteroid's orbit. In the upcoming weeks, scientists will investigate the system using James Webb's MIRI and NIR SPECT. The near-infrared spectrograph can cover the wavelength range of 0.6 to 5 microns. A spectrograph, also known as a spectrometer, serves to divide the light emitted by an item into its spectrum. The NIR SPECT will investigate the spectrum of the Dimorphos and offer us more information about its physical properties, such as temperature, mass, and chemical makeup. Dimorphos' atoms and molecules leave behind lines on its spectrum that serve as distinct fingerprints for each chemical element present. These lines can reveal a wealth of information regarding Dimorphos' physical conditions. The mid-infrared instrument observes light with longer wavelengths than those perceived by human eyes in the mid-infrared region of the electromagnetic spectrum using a camera and a spectrograph. Though the NIR spec can detect wavelengths of 0.6 to 5 microns, MIRI can detect wavelengths ranging from 5 to 28 microns. Its sensitive detectors allow it to examine objects in the Kuiper belt, as well as redshifted light from distant galaxies, newly forming stars, faintly visible comets, and other things. As a result, MIRI's camera will provide wide-field broadband images, continuing breathtaking astrophotography that has garnered Hubble worldwide acclaim. Medium-resolution spectroscopy will be possible with the spectrograph, and this will yield new physical information regarding the extent of DART's influence on Dimorphos. Spectroscopy and spectrometry are the sharpest tools in the astronomical study toolbox, and the spectroscopic data obtained from the MIRI and NIR spec will help researchers comprehend the Dimorphos' chemical composition. The Hubble telescope, like the James Webb Telescope, captured images of the binary system before the impact and replicated them 15 minutes later when the DART probe crashed into Dimorphos. Hubble's Wide-Field Camera 3 photographed the DART's impact in visible light. The impact ejecta is visible as beams stretching from the asteroid's body. The more noticeable, widely dispersed spike of debris to the left of the asteroid is in the close surroundings of where DART launched from. Astronomers will need to investigate further to determine why some of the rays appeared slightly twisted. Scientists also noted that the system's brightness in the Hubble telescope images increased 3 times more following the collision. Even 8 hours after the collision, they could still see the light remaining steady. A new mission, the Hera mission, has been created to investigate a crater left by the collision with a diameter of roughly 33 feet. It would depart in October 2024 and touch down on the asteroid in 2026. Scientists think this crater will be much bigger than what they are expecting, and a major chunk of Dimorphos was most likely destroyed. By calculating how much DART diverted the Dimorphos' trajectory, the world may begin planning to defend itself against larger asteroids that may come our way in the future. NASA stated in a press release that all of humanity is eagerly awaiting the results of the James Webb Telescope, Hubble Telescope, and our ground-based observatories concerning the DART mission and beyond. NASA estimates that it will take 3 to 4 weeks before an exact calculation can be done, and at least a week for telescopes and radars on Earth to provide a preliminary evaluation of how much the asteroid's orbit has changed. Hubble will continue to monitor the Didymos-Dimorphos system 10 times more than it has over the next 3 weeks. These continuous, somewhat long-term measurements of the ejecta cloud's expansion from ejection to disappearance will better illustrate its evolution throughout time. However, the more the amount of material and speed ejected from the crash, the more the deflection of the asteroid's trajectory. While these synchronized Hubble telescope and James Webb telescope observations are important operational milestones for both these telescopes, scientists can also combine the capabilities of both observatories to address lots of unanswered questions that we have been asking in science, like the composition and development of our solar system. So you have no reason to fret, just consider this a space military drill to protect our planet Earth. And on that note, we have come to the end of this video. What do you think about this collision, and do you believe that this test will disturb the peace of the Earth and the solar planet at large? Let us know what you think in the comments section below. Don't forget to give this video a thumbs up, smash that subscribe button, and turn on the notification bell to get notified when we post a new video.